part 3 in our series about linear equations. And there it is, the point-slope form. When you know one point and the slope, point-slope form is a great way to start. You can put those things right into an equation. In this case, we have slope of -3, and for the point, we're going to use the variables x1, y1 to represent the coordinates of the point that you know. The x1, y1 just means that we wanted variables that were related to x and y. We want that to be really clear, but we can't use x and y because we also have an x and a y in the equation. So let's plug those things in. Y stays variable y, and then we find the difference between that and the y coordinate that's given. So it looks like subtract -1. On the other side of the equation, we have the slope, which is -3, and we have the variable x and the difference between that and the x coordinate. So that looks like -5. Now when we have minus a negative number, like in the y side, we can change that to addition. So you could rewrite it as y plus 1 is equal to -3 times x minus 5. Okay, another way to say that is that this is y and the opposite of the y coordinate, and this is x and the opposite of the x coordinate. And that is what point-slope form looks like. Let's use it. So here's that same equation written out, and we're going to change it into slope-intercept form, which we know a little more about. All we have to do is solve for y. So we start with our point-slope form and simplify it. We need to distribute this -3, and then we can further isolate the y by subtracting 1. So our slope-intercept equation is y equals -3x plus 14. There it is. Let's use that to find a few points on this line. Now first of all, we know that the y-intercept is at 14. So I'm just going to write that in. 0, 14 is a point on the line. But for the other ones, I need to plug it in. So when x is 1, y equals -3 times 1 plus 14. So let's work that out. That would be -3 plus 14, which is like 14 subtract 3. So that would be 11. That's our y coordinate. Let's also plug in -3. So this time y would be equal to -3 the slope times -3 the x coordinate plus 14 again. So that's like 9 plus 14, which is 23, and that's the y coordinate. We're going to use these 3 points to sort of test out the point-slope form. Now according to the rules, we should be able to write the same equation using any of these points. So let's do that and compare them to the slope-intercept form. So for this one, we would get y minus 14 is equal to, remember the slope is -3 for everything, times x minus 0. And if we simplify that, we get y minus 14 equals -3x. But let's get y by itself. So I'm adding 14, and it turns into y equals -3x plus 14, which is exactly the same as the slope-intercept form. So now we've found this with 2 different points. That means these are the same line. So let's try another one. So y minus 11 is equal to -3 times x minus 1. And again, we're going to solve for y. So let's distribute the right side. -3x plus 3 is equal to y minus 11. And we need to add 11 to both sides. And again, we're getting y equals -3x plus 14. Proving that that's going to graph exactly the same way. It's just a different version of the same linear equation. I do want to try the last one because it's a little more complicated. Y minus 23 is equal to -3 times x minus -3. Let's change that to plus right away. Now distribute the -3 to both. So I've got -3x minus 9, and I still have y minus 23 waiting over here. So let's add that 23 to both sides. And again, y equals -3x plus 14. So what's going on here with point-slope form? Every point in the line is related in the same way. The x-coordinates are related to the y-coordinates mathematically the same way. And that's going on behind the scenes. When you plug in different points, it is still going to be the same line as long as they're points that are on that line. We see it when we simplify into slope-intercept form. So when you're given a point and a slope, This form is a great way to start your equation.